Hey there, fellow tool nerds. This is Doug, the professor, coming to you from my laboratory, where we hope to finally put to bed the debate over whether or not vinegar is a good way to remove rust from metal. Now, I don't think that a lot of people would disagree with the statement that vinegar removes rust. We know it does. The question is, what does it do to the metal underneath the rust? Does it damage it? And in today's experiment, we're hoping to see whether or not that is true. So the plan is we're going to start off with these two pieces of steel, and I have artificially rusted them so that we could have two different samples that would have roughly the same amount of rust. I know it's not going to be exact, but this is just a rough experiment anyway. So the first thing we're going to do is we're going to take one of these and measure its mass. And then I'm going to use some steel wool to scrape off as much rust as I possibly can. This will give us an idea of how much of the mass of this is actually rust. And then what we'll do is measure the mass again. Then we can look at this piece, and we're going to put that into the vinegar bath. And we'll see how much its mass drops. Now, if its mass drops by exactly the same amount or a similar amount as the other one that we just scraped off, that would tell us that the vinegar is probably just taking away the rust. But if we see a significant decrease in mass beyond that, then that's an indication that the vinegar is actually eating away the metal. All right, so I have started off by labeling these A and B. You can see those little lines I put on there just to indicate that's going to be the part where we're going to begin the experiment. We'll put A on the balance, and we get a mass of 9.7186. And then we put B, which comes out to be 9.6087. Okay, we'll call it there. Those last digits there are pretty far out. Now, the next thing we're going to have to do is scrape away everything below the line on B to get down to bare metal and see what the mass is afterwards. Okay, so as you can see here, I have cleaned B, both front and back of rust. For the most part, it looks pretty good. And here we still have all that rust that's on A. So the next step is to put this into a vinegar bath and see what happens. All right, so here you can see that I have plate A immersed in a bath of vinegar, and getting close to it. We're not seeing a whole lot going on here just yet. We'll give it a couple minutes. We're a couple of minutes into the experiment, and now you can already start to see little bubbles forming. Now, you might be looking at that thinking, oh, that means this is working. But it's working, but not necessarily on the rust. In fact, those bubbles are more likely a sign that the vinegar is acting on the metal itself. You see, when acids come into contact with a metal, what they do is they steal electrons from the metal. And what that does is convert the the hydrogen that's in the acid, to hydrogen gas. So each one of these little bubbles here that's forming is actually hydrogen gas forming, which tells us that the reaction is definitely taking place on the iron itself and not on the rust. The interaction between the acid and the rust does not form any gas. All right, so now you can start to see these bubbles that are forming and breaking away and floating to the surface. Okay, again, this is hydrogen gas that's being produced. But the important thing to really notice here is that the bubbles are not evenly distributed across the entire piece of metal. The bubbles are taking place where the reaction has kind of started eating into the metal and increased its surface area, which means you're going to have this reaction taking place more quickly at the places where it started than the places that it reaches later on. So what we have here is a reaction that's not evenly removing iron from the piece of metal. Or at least that's what I'm proposing. So let's take a look at the data and see what we learned. All right, so remember that we started off with 2 strips of metal. After 30 minutes in the vinegar, we only lost 6.5 milligrams of material, relative to the 10.8 milligrams that we lost mechanically with just the steel wool. 30 minutes isn't a long time. So what I did was I extended the experiment to 4 hours. And here you can see after 4 hours, we had lost a total of 11.7 milligrams, which was on par with what we got with our control. Now it's kind of looking like vinegar was only removing the rust itself. But again, 4 hours isn't a long time. And I noticed that the piece of metal looked fairly rust-free after those 4 hours. And I wondered what would happen if I continued to let this sit in a vinegar bath. And that's what we did. And as you can see, after about a day, we hit 22.5 milligrams lost. So if we continue to lose material even after it appeared that the rust was gone, I think that's a pretty good indicator that some metal is being removed. So what does all of this mean? Well, I think to answer that question, we need to address one of the big limitations in the experiment that we just performed. And that was that we were trying to rust two pieces of metal in an equal fashion, with hopes of being able to quantify how much metal was being removed by the acid relative to the amount of rust. And that's just not a calculation that I think that we should lean on right now. What I think was a very interesting piece of data was the fact that even after the rust appeared to be gone on the piece of metal, that additional treatment with vinegar led to more weight loss, which tells us that it's pretty likely that the vinegar is removing the metal. Now you couple that with the fact that we saw those bubbles, and I think that that's pretty damning that the metal is being eaten away by the vinegar. Now, this raises a whole bunch of other questions though. I mean, is the amount of metal being eaten away significant? Is it going to do damage to the actual tool? And I think that's going to largely depend upon whether or not the metal's being removed evenly across the surface, or if it's being removed more quickly in some places than others. And honestly, my gut feeling is that the removal of metal is probably going to be concentrated in those areas with the greatest surface area, which are going to be areas that have pitting and areas where you have things like etching and stamps and stuff like that in the metal, which means that vinegar might be particularly good at removing etches and removing maker's marks and things like that, in addition to removing the rust. But I think that's going to be the experiment for next time. But for now, I think we can all say unequivocally, vinegar eats the metal. All right, well, that was my first video. If you enjoyed this, please make sure you press the like button, leave a comment, and I will work on getting the next video out.